Okay, so we saw that working in an orthonormal basis would makes things really much easier to work with. All right. Let's read what's written. So, given an orthonormal basis, the scalar product is the same thing as the canonical scalar product in Rn. So this you had already figured out. So the question becomes then: can we always find an orthonormal basis if I've got some finite dimensional space, for instance? And actually, you already know the answer to that because I'm pretty sure you saw during semester one this stuff, the Gram-Schmidt autonormalization process that builds out of any normal basis, whatever basis, it builds out an orthonormal one. Okay, so we should take some time to work again on this so that you know how to make this, even if we're not talking about basis of whatever items you have. Okay, but even if it's not basis in R2 or R3, you can work out orthonormal, I don't know, polynomials, orthonormal functions, as long as you have the corresponding inner product that defines the orthogonality for you. Okay, so let's see that Gram-Schmidt. So what does it say? It tells you that, well, given an independent family, it doesn't have to be a basis. As long as it's independent, you can work out. We're going to work out an orthonormal independent family. If you have enough vectors, it makes, and you're in finite dimensions, you will make a basis out of that. Okay, but the important thing is that actually, given an independent family, we can build out of this family a new family where the vectors are 2 by 2 orthogonal and have norm of 1, such that both families span the same space. Okay, and it's going to be a constructive proof because we're going to use the Gram-Schmidt orthonormalization process. And so, if you remember, we make U1 being the normed version of we make E1 the normed version of U1. We make E2 out of U1 and U2. We make E3 out of U1, U2, and U3, and so on. So think about that. If you want to write the change of basis matrix from the first base, the old base, to the new orthogonal one, you will get an upper triangular matrix. Okay, and as a nice corollary, any Euclidean space, so Euclidean meaning that you've got an inner product and finite dimension. Any Euclidean space has an orthonormal basis. Okay, so let's remind you of this Gram-Schmidt orthonormalization process.